Hello, dear students. Today we will have video lecture on particular topic called IBF solution for the transportation problem. As I have shared the notes with you, in notes in particular topic I had given the steps to solve the transportation problem. And the first basic step is to form this transportation table and find out first initial basic feasible solution. It is also known as IBF, initial basic feasible solution. Okay, in notes I had mentioned three major methods to find out this IBF solution. First method is north west corner method. Second is least cost method. Third is Vogel's approximation method, VAM. Okay guys, we will do video lecturing on these two major topics. If you understand these topics or understand the logic behind how to find out this solution, IBF solution, it will be easy for you to solve it by VAM. Okay, then also I will provide you video link for this VAM. It is not possible to draw the bigger image for this table. Okay guys, so let's start with our first method called least northwest corner method. Okay guys, so this is a table you must have seen, you must have gone through my previous notes of the basics of transportation problem. Okay, these are the distribution or destinations D1, D2, D3. They have certain demands, like D1 have 120 units of demand, D2 have 180, D3 have 150. Okay, and then we have sources points like P1, P2, P3, P4. Like this is a plant location 1, plant location 2, plant location 3, plant location 4. Okay guys, and each plant have certain source or certain capacity. Like P1 can supply 90 units, P2 can supply 110 units, P3 can supply 150 units, and P4 can supply only 100 units, not more than 100 units. Okay, the source point cannot supply more than this particular supply capacity, whereas this destination points or demand center requires this much demand to be satisfied, not less than 120 or not less than 180, or D3 will not accept less than 150. For this, first we have to see whether the total supply and total demand is same or not. If you take a total, it is like 0, 0, 1, 9, 11, 4, 0, 9, 10, 5, 15, 1, 2, 3, 4. 450 for total supply, and if you see, it is also 450 for total demand. Total demand is 450, total supply is 450. Therefore, this particular transportation matrix is balanced. So we will now solve it through we will try to find out how much units should be shipped from P1 to D1 or D2 or D3 so that its supply is completely exhausted, or how much units to D1 can be supplied. Okay guys, once again, how much units to D1 can be supplied from P1, P2, P3 or P4 so that its demand of 120 can be satisfied. So we want to find out how much from P1 to D1 or P1 to D2 or P4 to D3 we should send. Okay, we should transport so that its D3 demand of 150 is satisfied, or its P4 of 100 units supply capacity is exhausted or completed. Okay, so as you know, this small boxes are the cost per unit of transporting from P1 to D1. Cost is 6. From P3 to D2, cost is 2. Okay guys, this is the basic understanding of our transportation problem. Next, as I told you, we have to find out how much units should be transported from each source to its destination so that the supply is exhausted and demand is satisfied. Let's move. So first was our northwest corner method. Northwest corner method. Okay, it says that we should start allocating to routes which is located at the top north and to the left west cell of this particular table. Like this of this particular table, P1 D1, this combination is at the top north and west left, top left corner of the cell of the table. So we will start first allocating here. Okay, we have to find out how much units from P1 to D1 can be shipped or transported. Okay, so basically like this, P1 can send, P1 have capacity of 90, so maximum he can send to or transport to D1 is 90 units. Okay, P1 का P1 D1 सेल हमने पकड़ा है, उसमें हमने पहले लिखा है supply. P1 can supply 90 units. How much D1 is required? 120 units. Okay, how much D1 is how much D1 is required? 120 units. Okay, so what is your suggestion? How much units to be supplied from P1 to D1? How much units to be supplied from P1 to D1? If you see, P1 cannot supply more than 90, but it requires, D1 requires 120. So what will the minimum quantity we can ship is minimum of both, which is 90, which is 90. Therefore, we will substitute here 90. We will send 90 units from P1 to D1. Okay, this is the first step of allocation. First, we have to find out how much units should be allocated from P1 to D1. We have allocated this. Now, if you see, P1 has sent 90 units to D1, so it doesn't have extra. Okay, so this 90 units has been exhausted. It only कुछ भी नहीं रहा. There is nothing left with. There is nothing left with P1. There is nothing left with P1. To D1, if you see, P1 had given 90 units. So out of 120, 90 units has been received. So we will update. Out of 120, 90 is received. Remaining is 30. This is the second step. Sorry, of updation. We have to update the supply and demand. Okay. Same thing has been explained in the summarizing table below the within the steps of the northwest corner methods in the notes. Please refer to that. Next, as P1 supply is exhausted, we will remove this particular supplier from the table because it is not of use for us now. Okay, guys. Now, remaining table is P2, P3, P4, D1, D2, D3. This is our remaining table. Again, we want to start from, okay, P1 is exhausted, so we have neglected P1 because it doesn't have any capacity left with him, with itself. So our new, okay, so our new table is P2, P3, P4, D1, D2, D3. This much. Forget about this now. Okay, guys. So now once again the rule is same. Find out the cell at the top left corner of the table. So top left corner is this one. Okay. Okay. So let's once again. So our next cell is P2 D1. P2 D1. How much capacity available with P2? 110. Okay. And what is the demand required by the D1 now? The new demand is 30. Okay. So D1 requires 30, but P2 can give 110. But what we will do? We will select minimum. So allocation will be 30 units. Okay. So we will allocate here minimum quantity 30 units. And we will, after allocation, we have to then update the demand and supply, the capacity and demand. So 30 is with 30 हमें मिल गया है D1 को. So there is no further demand, 0. 30 gaya. P2 has provided 30 to D1. Therefore, we will minimize 30. Remaining are 80 units. Now, if you observe, we have to neglect someone, or the someone's demand is satisfied, or someone supply is exhausted. So if you see D1 supply is now satisfied, it doesn't require more units. So we will remove this particular player from the table. So we'll cut this and cut this line. So remaining table is P2, T2, D3, P2, P3, P4, and this is our remaining table. Again, we have to select the route because there are still some quantity remaining, capacity remaining, demand has not been still satisfied. So again, north west or top left corner of the table. Top left corner of the table is this one. Okay, guys. So P2, D2. Now we will change our selection. Our selection is now P2, D2. P2, D2. Okay. So available capacity with P2 is now 80. Okay. And D2 requires 180. D2 requires 180. Okay. D2 requires 180. So what we have to find out, how much quantity should be allocated to this particular route P2, D2. If you see, P2 cannot give more than 80. So minimum of 80 and 180 is 80. So we will select minimum of the capacity and demand is 80. So we will allocate here 80. We had allocated the unit to the route. Now we will see whose capacity is exhausted or whose demand is satisfied. How much demand is satisfied? If you see, P2 has given 80 units, which was remaining 80. So it has been exhausted. Capacity has been exhausted. For D2, 80 has been received. So we will cancel 80 units from this. The revised demand will be 100. Okay. So someone has been exhausted. P2 has been exhausted. P2 has been exhausted. So we will remove P2 from the table. We will remove P2 from the table. Okay. So sorry. Again, the table remaining is P3, P4, D2, D3. These 4 cells has been remaining. Again, same rule. Top, north, top, west, left. Top left corner is this P3, D2. So our new cell will be P3, D2. P3, D2. Okay, this is our selected cell. P3 can provide 150 units. How much D2 requires? 100 units. How much D2 requires? 100 units. Minimum of the both is 100. Okay, because D2 requires only 100 extra. It is possible to supply more, but it requires only 100, so we will supply only 100 units to D2. So it becomes 100. Now we will update the demand and supply. First we will update the supply. Out of 150, 100 has been utilized, remaining is 50. Out of 100, 100 has been received, remaining 0. So D2 supply or D2 requirement is exhausted or satisfied. So we will remove this particular player from the table. Remaining are only these 2 cells. If you apply the rule, top left corner. This is the cell, top left. Okay. P3. So the cell will be, so new cell will be this one, P3, D3. P3, D3. The route is P3, D3. P3 can provide 50, D3 requires 150. Okay, P3 cannot provide more than 50. So minimum of those two 50. So we will allocate 50. We will update then. Supply 50 out of 50 has been given 0. This is 100. Okay guys. Next, this has been exhausted. You can cut it, or simply you can see there is only one cell remaining in this particular problem. In particular cell, and if you see P4 can give 100, D3 requires 100. So it matches everything. So we will provide this 100. So there finishes our northwest corner method. Allocation by northwest corner method. If you see, we had allocated P1 to D1 90 units, P2 to D1 30 units, P2 to D2 80 units, P3 to D2 100 units, P3 to D3 50 units, P4 to D3 100 units. If you calculate the cost, we are not transporting from P1 to D2. We are not transporting from P1 to D3. It is 0. Okay, we have not selected these routes according to the logic. So what is this cost of this particular allocation? The cost will be like this: 19 to 6 plus 30 into 3 plus 80 into 9 plus 100 into 2 plus 50 into 8 plus 100 into 6. This is the total transportation cost. Okay guys, so you have finishes our thing. I had provided answer in our notes. Then there is one more condition. There is one more condition that is known as Ream condition. That is m plus n minus 1. Okay, the value of m plus n minus 1 should be equal to number of allocations. Okay, if you see, what do you mean by m? M are the number of sources, or n is number of destination points. If you see how many sources are there, 1 2 3 4, 4 sources. How many destination? 1 2 3, 3 destination minus 1, the value becomes 4 plus 3 7 6. Okay, and number of allocations. So wherever we had allocated from this to this 1 2 3 4 5 6. Since these two values, as per the logic, these two values rule are same, therefore the Ream condition is satisfied. Okay, further things has been explained in notes. Please go through the notes.